Vocal communication within animal groups is one of the most important tools used throughout the animal kingdom today and can be used to communicate certain auditory vocalizations or vibration changes. The vocal output and spatial arrangement of individuals in these exchanges provide the physiological basis concerning their function. The iconic whale song, in comparison to the bird song, differentiates sound between the marine versus terrestrial environments. The frequencies and diversity of these songs provides us with an important model of vocal development, complexity, and variability. How these songs are projected and their frequencies transmitted both through the marine and terrestrial environment is what will be compared today.
To begin, we'll start with birdsong and how it is just one part of their vocal repertoire and look into how they project these sounds. Songbirds learn their songs and perform them using a specialised voice box called a syrinx, which resembles vocal cords in function but is significantly different in form. Syrinx is an organ located at the base of the trachea where it splits into two bronchial tubes. This causes the syrinx to become a resonating cavity with highly elastic vibrating membranes. The intensity and frequency can both be varied by altering the air pressure travelling from the lungs to the syrinx and the fluctuation of tension by the syringeal muscles on the elastic membranes. The frequency and duration of song varies with different species, and many birds have different dialects and variations which develop in isolated groups. In songbirds, two unrelated pitches can be produced at once due to each side of the syrinx being independently controlled.
In comparison, the beautiful whale symphony is a unique set of sounds projected for a number of different reasons. It is not 100% known why these majestic animals sing, but some suggest it could be to mark their territory, coordinate migration, communicate to their young, or the opposite sex to look more attractive. Cetaceans are heavily dependent on sound for communication, and only a few species of whales are known to sing, which are the baleen, blue, fin, humpback, bowhead, and minke whales. Whales use a U-shaped fold of tissue between the lungs and the large inflatable organs, called the laryngeal sacs, to produce these echoes. Scientists suggest that muscle contractions in their throat and chest move air from the lungs across the U-fold and into the laryngeal sacs. This causes the U-fold to vibrate, and the resulting sound echoes in the sacs, sending songs thousands of kilometres away. Whales don't exhale to sing. Air is simply recycled into the lungs, creating the sound again. This song is patterned and varies in duration, and just like the bird song, each population have sounds significantly different.
One study found that whales produce different patterns of pulses, tones, and pitches to communicate, which can also be seen with many different species of birds depending on where they're from. After many generations, the birds and whales from one area can sound quite different to another due to geographical separation and speciation in subpopulations. The speed and sound is roughly 4 times greater in water than in air, and as discussed with birdsong, they generate sound by moving air over their syrinx, whereas whales recycle stored air to echo over the U-fold and into their laryngeal sacs. From this, it can be seen that both whales and birds use their sound for very similar reasons, but the production of these different tones and pitches have evolved over time to best suit the environments they live in. So are birdsong and whale song really that different?